I'm Brennon.
I'm Bryce.
And I'm Charlie, and this is the grip retention project.
Here we have the schematic for our grip retention system. First, we have the embed subsystem, which is our free-scale controller. It has 3 analog inputs and 2 digital outputs. Those 2 outputs go to our H bridge, which, depending on which one's high, will change the direction of our DC motor. And our over torque subsystem stems off of our motor, and it utilizes the fact that current is proportional to torque on the motor, and we have our R5 and R6 chosen, where we drop the voltage from about 12 to less than 3.3, so it's safe for the embed. Lastly, we have our start and stop buttons, which start and stop the program.
So here we have an overview of each subsystem. We have the overtorque subsystem highlighted in yellow. We have the H-bridge subsystem highlighted in green, and we have the start and stop buttons highlighted in blue. And you can see all the analog ins and digital outs going to the embed from the top of this line.
Here we have a pinout of the embed. First, we're looking at the analog in, which is where our start, stop, and our over torque signals will enter. From here, we have our digital outputs, which are either on or off, and these are our forward and reverse. And here we have a couple more supplemental features from the embed, including the 3.3 volt power supply, which we've used for our buttons so that the signals would be safe for the embed.
Here's our embed, and we use an online compiler to write code for it, and we upload it using a USB cable. After it uploads, you just press the reset button, and it's ready to go.
So here we have the first few lines of our code. We have the analog in pins, the over torque, the start button, and the stop button. Then we have our digital outs going to the H bridge and powering the motor. We have the forward and reverse. Then we have our which is the float limit, which is the limit for the over torque, and then we just have a simple Boolean set to false.
Here we have a cutout from tare-term, which is the serial monitor that we use to monitor the inputs entering the embed. Above is the code that we use to print out onto tare-term. As you can see on the numbers in this cutout, our motor, when it turns on, shows us an over torque of 0.173, which is below the limit, so we implemented a wait so that the motor gets a chance to start moving before it's turned off. After this, it hovers around 0.315 until it experiences over torque that takes it below 0.314, which is the limit we have set. Here you can see where we have implemented this line of code for the printout. Now we have this code, and we've written it all within a main method and inside a while loop that is running continuously. Inside this while loop, we have 2 conditions. One is if the stop button is pressed, which will cause our forward to turn off before it waits 0.3 seconds, and then turns our reverse on for 0.4 seconds before turning our reverse back off. This means our motor will go backwards just a little bit. Under the start condition, once the start button is pressed, continue will become true, which will allow our while loop to begin running. Under this while loop are 3 conditions. The first condition is the stop condition number 1, which is our emergency stop. Under this, you can see that if the stop button is pressed, forward becomes 0 and reverse 0, effectively stopping the motor completely. You also see that continue becomes false, which means that we will be able to break out of this while loop, so this next condition will not continue running forever. This condition is the else, and basically, as long as the stop button is not being pressed, our motor is moving forward. This wait condition is introduced because to allow the motor to get up to speed, so the over torque condition is not triggered too early. The last condition we're looking at is stop condition number 2, which is over torque. Here you can see that it is basically the same code as stop condition number 1. However, the condition is different, with this condition being if over torque is lower than our limit.